All right, so on the back of this sheet, this section 11.1 is just full of stuff. It's silly. They put a lot of stuff in here. So I try to put the main points down here. The first thing I put in there, a little side note, a little side theorem here. It's that the limit of the absolute value is something, and the limit of the function itself must be the same thing. Let's think about that. What do you guys think about that? I mean, that's sort of related to what I was saying earlier about, well, if it's going to 0, I don't care that I'm bouncing around 0. It's still going to go to 0 no matter what. So if I have some L, and my actual function is bouncing around this thing, but always getting closer to it, then of course the minute I start taking absolute values, you know, and in this case nothing's negative, but let's pretend like this is 0, then it's still going to approach it, right? It's got to. So just taking out that -1 dependence is really not going to change anything. Even if that function is oscillating, then this one would still be oscillating, right? The absolute value of a sine goes from 0 to 1. It's still going to have the same problem, so it's still not going to have a limit, right? So it doesn't really mess with that. Okay, so that's a little side limit idea. Now here's a bunch of definitions. And really, what I want us to get used to is the idea of something being monotonic. So of course, what's monochrome mean? Monochromatic. Besides another fun word to say. One color, right? So if you're an art student, you have monochromatic something or other. It's just that one color. That's all you got, right? So monotonic sequences only go in one direction, at most. And what do I mean by that? I could have a sequence that does this, right? Or if it's a sequence, it'd be dots, but you get the idea. There's like a step function thing. So it stays the same, and then it goes up, and then it stays the same, and then it goes up, and then it stays the same. So what I can say about that is it's never decreasing, right? So it's like the difference between positive and non-negative. Those don't mean the same thing, do they? What's the difference? Non-negative includes 0. So non-decreasing includes the chance that it's staying the same, right? Or if I said strictly increasing, it can't stay the same, can it? So this is non-decreasing, and I think from that explanation, I think you can figure out what the other ones mean. Non-increasing, same thing, except it's stepping down. That's incredibly exciting. So this is still, I would call this monotonically increasing. If it's strictly increasing, I call it strictly monotonic. So it can't stay the same, right? How are we doing? So monotonic means it's at most only going in one direction, if not staying the same. Strictly monotonic, it can't even stay the same. It must be increasing all the time or decreasing all the time. Now let me throw something at you now. With all that said, if I have, let me just ask you this directly. If I have a sequence that is monotonically decreasing, right? So I have a monotonically, I don't know if that's how you spell it actually. I'm trying to make an adjective out of a word. Decreasing sequence. And it's got what's called a bound, meaning there's a lower bound to it, right? Like it never goes below something. So I got this sequence is monotonically decreasing, and there's some kind of a floor that it never goes below. What can you say about that sequence? So it's forever, and it's not strictly monotonic, right? So it could be staying the same. But what must that sequence do then? What must be true about that sequence if I let n get really big? It's got to approach a limit. It's got to. It can't turn around. So either, that's the floor. Does that mean I actually have to hit the floor? No, if I hit the floor, then I'm there forever, aren't I? Right? So that's kind of an extreme case. The minute I hit the floor, I ain't getting back up because I'm decreasing, right? That's it for me. But what can he do if he doesn't hit the floor? What would that mean? If he doesn't, he's staying the same, and then maybe goes down a little bit, stays the same, goes down a little bit, stays. So maybe he hits somewhere that he stays the same for there forever. That's still got a limit. That's his limit then, isn't it? So either he makes it all the way down to the floor, and therefore the floor is the limit, or he has some other place, and that's the limit. There's just no other. There's nothing else that could happen. He could start here and just stay there. That's still monotonically decreasing officially, really, tell you honestly, because it's not increasing, is it? But then that's easy. The limit is that. Ooh, right? Okay, maybe. So this idea of bounded means I got like a floor or a ceiling, right? So bounded below, bounded above. If I just say I have a bounded sequence, that actually means it's got both a floor and a ceiling. So like a sine function is a bounded sequence of numbers because it can't go above 1, it can't go below -1. So we already know a function, we just never called it bounded probably before. Okay. So this is really Theorem 12 in the book. Theorem 12, I can't remember what page it's on, but monotonic sequence theorem. So every bounded monotonic sequence must have a limit. And if you really think about it, it's like, well, yeah, of course. It can't oscillate away. You know, how can you get away from having a limit? Either you go to infinity. All right, well, that can't happen because it's got a floor and a ceiling. Or you oscillate yourself away from a limit. That can't happen because it's monotonic, right? You've taken away all the ways to escape a limit. Therefore, the damn thing must have a limit, right? Okay, maybe. So let's try this. These exercises here, this is what I want to get to today, and we're going to stop here as soon as you guys get done with this. The first step of this is that what we did earlier, I want you to write an A sub n equals what? A closed form is what it's called, a closed form for that sequence. And then tell me if it's monotonic, strictly monotonic, or neither. Is it bounded? And then see if you can figure out if it converges. So try those out. And of course, call me over if you need some help. So the very first thing is try to write A sub n. What would that look like?